Okay, so my video recording only gets 20 minutes of recording at a time. So here we are, example 3. Pause the video, look through example 3. And now we're back. There is a special type of block design. And again, block design is when you split right away based off of a variable, like in this case gender. There's a special type of block design. It's called a matched pairs design, and it's a special type of block design with block usually of size 2, in which two very similar experimental units like twins are paired, and two treatments are randomly assigned within each pair. So you'd have twins number 1, okay? And then you'd randomly assign treatment A and treatment B. And you'd have twins number 2. And one twin would get treatment A, one twin would get treatment B. And then you got twins number 3. One gets A, one gets B. And then you compare the whatever you're doing to the twins. Maybe it's a math test or something. I'm thinking math now. But that's called a matched pairs design. A matched pairs design. It's when you block by a very similar trait, like twins. And then you impose treatment A to one twin, treatment B to another twin. Alright, this is the last page here. Something called a control group. A control group is an experimental group that does not receive any treatment. It's called a control group. I guess I don't need that parenthesis right there. In experiments that use human subjects, the use of a placebo may be necessary, and a placebo will act as like a control. Placebo, something that is identical to the treatment received, except it contains no active ingredients, like a pill. So if you're experimenting on whether or not a pill affects a cancer, you're going to take your group of individuals that are getting the treatment, you're going to randomly assign some of the individuals to get the pill with active ingredients, and you'll randomly assign some of the individuals to get a pill that does not have any active ingredients. The pill that has no active ingredients group will be called your control group, and they'll be getting a placebo. Alright, the control group does the following for the experiment. 1, it allows the experiment to assess how the response variable behaves when the treatment is not used. Alright, or like in the calc example for temperature, if we just had a group at normal room temperature, it would be our control group. Provides the baseline against which the treatment groups can be compared to determine whether the treatment had an effect. Alright, so yeah, the baseline. Example 3. Consider the room temperature experiment from before with the calc classes. Was there a control group or a placebo? And I would say no. No, because we had two treatments. We had 65 degrees and 75 degrees, and it's not like we had a normal class conditions versus a hot class conditions. We did not have a placebo either. Example 4. Consider Anna a waitress. She decides to perform an experiment to determine if writing thank you on the receipt increases her tip percentage. So think about how she would do this experiment. Alright, she's got a certain number of receipts, a certain number of clients, we'll say, I don't know, people getting food. She plans on having two groups. One group, she will write thank you, that's one treatment on the receipt, and the other group, she will not write thank you. It's no treatment. That's your control group. Which of these is the control group? Well, the control group is just the normal situation. It's the receipts that do not have thank yous on them. That's the control group. Alright, back to the room temperature experiment. Would the students in each section of calculus know to which treatment group, 65 or 75, they were assigned? Should we tell them we're even doing an experiment? I don't even know. Maybe just tell them at the end. They'd probably know the difference between a 65-degree room and a 75-degree room. But in general, an experiment in which the subjects do not know which treatment they're in is called a single-blinded. So single-blinded means the subjects do not know. Only the subjects. The experimenter still knows what the treatment is. A double-blinded experiment is one in which neither the subjects nor the individuals who measure the response knows which treatment is received. Okay, so single means just the subjects, whereas double means neither subjects nor the observers. Is this experiment single-blinded, double-blinded, or not blinded? The room temperature experiment. Do the subjects of the experiment know which temperature they're getting? And we would say, probably not. I don't know. It didn't say that we told them. So it's definitely single-blinded. Is it double-blinded? I would say no, because the experimenter who's measuring the response knows. So I would just call this a single-blinded. You could make it, I guess you can make it double-blinded if you had the instructor grade the assessments without knowing that there was an experiment happening. It's possible. Alright, next. Using volunteers as subjects in an experiment is okay. You can use volunteers. You need volunteers. However, in an observational study, if we remember the last lesson, when you use volunteers, that's an opportunity for bias. So in an observational study, volunteers are no good. In an experiment, volunteers are okay. It's better to randomly pick people for an experiment, but sometimes you have to rely on volunteers. So remember, using volunteers in observational studies is never a good idea. However, it is common practice to use volunteers in experiments. When you use volunteers in experiments, the random assignment of the volunteers to the treatments can still allow for a cause and effect relationship. Because if you remember from a previous lesson, the only way to show cause and effect relationship is with a well-designed, well-controlled experiment. You cannot show cause and effect with an observational study. You can only show cause and effect with a well-designed, well-controlled experiment. The difference is if you use volunteers, it limits your ability to generalize to the population. Alright. Now, example 4, what I'd like you to do now is pause the video and read through example 4 and see what you can come up with for yourself. So, pause the video. And we're back. If this was a normal calc class, we would get together and discuss these things in groups, and then we discuss them as a class. Unfortunately, this is life now. Okay. So, there was an SAT prep class offered. Students could volunteer to take the course. 44 students took the course and then took the SAT. The average SAT score for the group was 1220. The average SAT score for all students who did not take the group was 1050. Is the situation described in an observational study or an experiment? You might think experiment. However, there's no treatment imposed. So no treatment imposed. We are just merely observing the results. The students are not forced to take the class, whereas in an experiment, you're actively putting some students to get treatment A, and you're putting some students to get treatment B. To make this an experiment, we could do a simple random sample of the students at CHS, and then some of those students would get the prep course, some of those students would not get the prep course. So we're not actually imposing any treatment. We're observing what's naturally happening. Okay, so this is not an experiment. Identify the explanatory variable and the response variable. Okay, so the explanatory variable is whether or not they took the course. The response is the SAT score, the outcome. So how is the response is like your dependent variable again, and the explanatory is like your independent variable. So independent variable, taking the course or not. Response, performance on SAT. Number 3, can you conclude that taking prep courses will cause, you gotta be careful with that, will cause a student's SAT score to increase? Because if you look at this, it looks pretty good. The people that took the SAT prep course did quite a bit better than the people that did not take the course. And you might be tempted to say, well, taking the SAT prep course causes an increase in SAT score. You might be tempted to say that. And the answer to 3 is no. Students who take the course, there might be confounding variables. For example, they might be more motivated. So you have to think of these factors that could go into the performance. Students who take the course might be highly motivated, so they study more anyways. What we need to do is do an experiment. If we want cause and effect, you need to randomly assign some students to take the prep course, randomly assign some students to not take the prep course, and then compare the results of that. And then you have to think of blocking. Are there other confounding variables that could affect that? Number 4, what are the other confounding variables? All kinds of stuff. Desire to do well, after school stuff, conflicting with being able to take the prep course, whether they're college bound or not might affect them, whether their parents are involved or not might affect how they value education, that sort of thing. So value in education, how well do they value education? That's a confounding variable. So there's all types of confounding variables. And then lastly it says design an experiment that would allow us to determine if the SAT prep causes an increase in SAT scores. Be as thorough as possible. Okay. So I'm not gonna write it out, but we'll just describe something. So for example, we're talking about juniors. Let's say we have juniors, because juniors take the SAT, right? We randomly choose 100 juniors. These would be our experimental units, the 100 juniors, to be a part of the experiment. We'll say. How do you get 100 juniors just randomly? You could do an SRS. You could give every junior in the school slip of paper, number them, identical slip of paper, put them all in a hat, pick out numbers. We now have a random number of 100 juniors. And then we randomly split them up so that half take the prep class and the other don't. Alright, so you start with your experimental units, your 100 juniors. Why 100? Well, I think 100 would be appropriate for, that's enough repetition. Why just juniors? Well, we could do juniors and seniors, but we would have to do a block design with juniors and seniors. So these people will get the prep course, do random assignment, these people will not get the prep course. Alright. You could randomly assign them equally, but because there's so many, 100, it doesn't necessarily have to be equal. You could do like 60. Maybe randomly 60 get put here and 40 get put here, and that's okay. As long as you have enough repetition, your groups don't need to be exactly the same size. Alright. Typically you do if you can. So we'll put half of them here if we can. Put half of them here. After the course is over, all 100 juniors take the SAT. So these take the SAT. These take the SAT. You compare the results. There's our well-designed experiment. And that is that. So that's a well-designed experiment. Oh. Alright, the last page is another example, and I'm not going to read this through to you. You can read this on your own. That was a lot of talking. I don't need to talk anymore. This is kind of like an outline for how you're going to do 139 in your homework. Alright. It says check the back of the book. I'm going to have the solutions online for you to kind of check your work with. Now, this assignment is due at the end of next class. So the homework was to watch the lesson. Classwork is to do the assignment. Alright, that's all I have for you. That was a lot of talking, I'm sorry. This is life. Bye.